platform that you're trying to build.
Yeah, and
Mm-hmm.
we're very happy to have you as part of our Dhyuti Talks, and you being our fourth speaker.
Okay.
Yeah, so I don't know. Yeah, so so we have Dr. Abhinav Srivastav, for those who just joined, and he'll be talking about TraceML, a package that he has written up for profiling Pytorch ML models that you could build for any particular application, right? So I would hand it over to Dr. Abhinav to talk more about it. Thank you.
Okay. Thank you, Rahul. Yes, so maybe I can start with showing the GitHub. Um,
Yeah.
I don't know if you can see my screen. Yeah. I'm going to switch off the camera because even my internet is not
Yeah.
great at this point.
Yeah, I'm going to switch it off as well.
Okay. So, yeah, I have been building this tool called TraceML. Essentially, the problem that I interfaced or came across when I started doing model training, even the large model training, is this out of memory errors. And it was quite frequent that this problem happened, especially on GPUs if you are trying to train a large model. And also, I wanted to see what is taking so much of time, right? So, good thing about PyTorch is that it is very modular in nature, and you can write different modules. But how do they interact overall and with the system? It's it could be like cryptic, right? So you just get, hey, you ran some matrix multiplication on a kernel level, and you got out of memory issues. Or maybe it's that your training is particularly very slow, right? And there are many parts to it. Like, why could it be slow? Data loading time, some memory leakage. And when I looked at PyTorch profiler, so this is where majority of uh, profiling is being done in this area. I found it pretty like exhausting. It's quite big. It's quite extensive, quite low level of information. And I thought maybe, and even then, like it gives you details which are very nice, but it doesn't provide you the details at the level that I needed it.
Hmm.
So I started building this for my own, let's say, work. I started building this model inspection code, essentially to look at how much memory the models take, like the machine learning model. So you have different layers of machine learning model, and each layer can take some time, some memory, and that gives you kind of an understanding of what is actually happening, if there is any particular kind of leakage that might be happening. So this is the GitHub for it. It's as I said. So when you actually run, I'll show you in the demo. What it does is it shows you the system level information, like the CPU,
Mm-hmm.
RAM, GPU. This is not new, but it is simple to show it on the screen. At least you have all the information at the same place.
Okay.
You also get this information for process level. Sorry, any questions?
No, no, no questions.
Okay. Um, and then what it does is it at a layer level. So each layer of neural net that you have, it will show you what is the memory, like how much memory does it take as a parameter. So when you try to pull this model onto the GPU, how much information memory is going to take. Then how much memory is going to take when you do the forward pass and the backward pass. And that was the original start like idea. Then I got the reviews about timing. So obviously the slowness is one of the things that I had in mind, but I haven't implemented. But people requested feature, and I kind of made up this step timing. And I'll show you how to use this. What you do here essentially is you just use simple timers, simple decorators, and the decorators kind of help you to get the timing details. So the installation is pretty straightforward. You can get to this GitHub. It's publicly available. You can download to pip install. And So we can go to the usage part. But before we go there, has anybody any questions, particularly related to what I have said till now? Maybe.
No.
Okay.
No, none from my end as well. Yeah.
Okay. So then it's good, right? So here is the. Oh no, sorry. I was running the code before the call. I saw that it wasn't running; it was changing something. But here's an example that I made. So this is a very simple example. It's all it does is takes a CNN. It's a built CNN so that I built it. It has a couple of convolutional layers, max pool layers. There's a flattening, and at the end you're trying to predict some classes. So it is running over a MNIST dataset. It's quite known dataset, and if you work in PyTorch, it should be very straightforward what is happening at this point. I suppose this is just a model being defined. We will get into this a little bit later. So these are the actually how do you use them, but I will get into it later. And once you have a model defined, you figure out the device that you have. In my case, since I'm working on a CPU of my own laptop, so it will be a CPU, but the code works for GPU also. It's simpler. Otherwise, I will have to go and work it somewhere else. And so once you have a model definition, once you have a model instance, right, this is where the TraceML comes in. All you have to do is pass the model to it. So you call this TraceML instance. It's available in decorators. And you just part that particular function in your model. What it does internally is it decorates it. So in the sense that it provides hooks, and when the activation will run in a forward pass, those hook will run after the activation has been done. And similarly in the backward pass. So it's not actually doing a computation, it's just looking at the memory values. This is standard, more or less, optimization and loss function. And this is where, so if you see, there is nothing happening here. It's a standard code. But what I have done for each of these functions, for example, get next batch, which is actually getting you the next batch, is being decorated with another decorator that I wrote, which is about where you have to pass in the information about the name of the time step that you're trying to measure. And is it a GPU or a CPU computation? So it works for both of the cases. It doesn't have to be fixed with CPU or GPU. And I can show you another example that I have. And similarly for the model forward pass, the backward step, and the optimizer. So you can have multiple of such activities nicely rotated in functions or methods which are decorated. And then this is a pretty standard training that goes through, right? And let's run the code. So this is all that used to be done from the user's perspective. From the end user's perspective, all you have to do is decorate your functions with some functions that my code provides. When it comes to running, so you can install it. This TraceML is available, and the way it is there. So this example is in the this particular location. All you have to do is TraceML run, and this will when you run it, it will open up a terminal within the terminal, a rich terminal, what is called a nice space, and you can see what's happening live. So this is your system, how it's working. I don't have a GPU available. I have what is again what host process is doing. You have different layers, how much memory it is taking, what is the percentage of memory, what is the current activation that is there, what is the peak activation. So it's essentially kind of maintains the historical information. Oh, sorry, it ran. And similarly for gradient and time. And at the end, it provides you the summary. So the summary information is like how many samples it collected, and this one is pretty small, purposefully. And again, for each of the blocks, it has a summary. So it gives you which are the top 3 activation layer, top 3 gradient layer, how much memory in total, let's say, the gradient took. It's an approximate, it's not, and the same goes for the activation. And you also have for each of the decorators that we used for measuring the event, how much time on an average it took and what is the peak time. So this helps you to figure out where the slowness is coming from. Maybe that often it is in the data loaders that happens, that it's not completely parallelized. Okay. Now, what happens is since the screen is kind of filled with rich terminal, at the end of it, all the logs that are there, so this is ongoing process, but all the logs that you're generated by the standard output is saved in your log file. So you can actually go there and see it. Yeah, this is the log file. This is all that is saved. So your solutions or your printf is not going anywhere, even though it's not shown the entire thing. There's a scrolling thing that is happening. It is actually saved somewhere in the location. Yeah. So that is the brief about how the tool works. Now, the good thing about the tool is that the tool doesn't only work in terminal. So you can use actually in Jupyter also. And also it works. So now building a dashboard. So where you can actually just do a mode as a dashboard. And it will pop up a nice web browser for you where you can see these things. So this is still in a production. It's still being built, so it's not completely done yet. That is all about the tool. What are the next steps? So before going that, yes, I did write up how the tool works. Is there is a README here nicely which tells you how it works. Again, the same thing. You can see you have functions. All you have to do is pass it into this, and you can decorate it also. There's two other options. There's a step timing performance. So you just decorate it. In this case, as you can see, there is a GPU used there. So these are in for the GPUs, but it will figure out if it is not for GPU. So even if you write it through GPU, doesn't mean that it will wait for GPU. It will figure out internally if GPU is available or not. So this is for training BERT, which I have shown, where you have this couple of layers. Again, the same thing, the memories, the percentage of memory, how is the activation going, how has it historically been going, the same for gradient, step timers, and what is the maximum amount of memory the activation and gradient take at any point. So this kind of gives you the picture, a memory map, what is happening. There is a notebook example. I haven't seen it in a while, but yes, so it works almost similarly. You have to do decoration in notebooks. The only difference in the notebook is that here everything is happening through CLI command line. So it's easier. It's hidden in the background. But here you would have to run the background yourself. So this is your training model. It's now defined in a function, and it's doing the same thing, nothing special. But you would have to call something called as a tracker manager. It's available in the TraceML, and you would have to start that manually. So this will not start automatically in the case of notebooks because there is no CLI happening. You have to run the each cell block. And yeah, here is like the end result. It's been shown here. So again, the same results will happen. It will have a dashboard running there in the notebook, and towards the end, you will have a summary of what has happened. So that is all to it. I suppose, yeah. Any questions? Anything until now that you might have in your mind that you want to know about the program?
Okay, so just one question. So this is compatible only with Pytorch at the moment, is it?
Yes. So the way it works is that it hooks into the model. So when you do activation forward pass in a neural network, like if you compute the value of the model, at the end of it runs. So it's kind of very, very tuned towards PyTorch. It will not work for anything else. It's only works for PyTorch. But if there is an interest at some point, I will try to figure it out how to do this in TensorFlow or JAX. But for now, it's more about PyTorch profiling.
Okay. And I think I think this must also be easy to adapt to PyTorch Lightning as well, right? So you anyway call uh, n torch and n modules, define that within a PyTorch Lightning module. So I believe we could bring in this as a callback or some sort of.
Yes, I suppose so. I haven't trained it, to be honest, on it. But the PyTorch module, it's might be more easier also because there is already modules happening. It's not, bunch of code written. You have to already write things in a nice function calls. It might be easier, though I would have to see what happens when you there is torch no grad kind of thing happening in somewhere
Okay.
because internally it calls it no.
Yeah, yeah.
So, but I haven't checked it. I suppose it will work. Again, if there is interest, then I can look into it.
But I think the
Um,
torch no grad would be called when you are running inference or validation, right? While training, how does
yes,
it?
it's supposed to be. While training, it shouldn't be doing it. Yeah.
Oh, so one more follow-up
Um,
question to this.
yeah.
So does it mean
Mm.
that you would be able to profile only if there is if the gradients are attached computational graph or something? Is
No, 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 no. So I can show you the internals of it, which is a little bit, but in a sense that it will work for the parameters. So you will get the parameters by default.
okay, okay,
You will get the activation because whenever you do, even with no grad, it's doing the activation forward path. You will not get any results for gradients essentially. So it will try to hook it up, but then you said don't save it, so it will not save anything anyway. There will be no backward pass, right?
yeah,
So when there is no backward pass, it doesn't fill up the memory. Um, yeah. I wrote also a small article about the same thing, which is, this is, I think, how Rahul saw this, right? So it says the same thing, tells you how it works. Now, a lot of people have asked about one thing in particular, that how much time does it take? So I haven't sampled it. I don't have, but what I have known and what I have seen it, so I don't have concrete numbers if you ask me for tables, but what I have seen, it doesn't take a lot of time to do this. The reason being, all of this memory that is being shown, so all of the memory resides in GPU. At no point I am shifting it to CPU. So there is no mem copy that's happening.
okay,
All I'm doing is looking at metadata, right? So tensors are there, they have metadata, how much memory is there. I'm just noting that things out. So that is pretty fast. Now, when it comes to display or anything that is the profiler doing, that's a separate thread happening. So the way it works is that there is a thread that runs in behind, and this is why you need to start with notebooks. And that thread actually collects the sample. So samples are collected by the main code. It is pushed into a queue, which is like a producer, and then there are consumer, which is basically a tracer manager, which goes into the queue and sees what is there and then tries to compute and save it. Um, so yeah, I think everything is explained here. Also, if somebody wants a little bit more details about how it works, why it works, what is the next thing that I'm working on right now is the JSON export. So essentially pushing everything into the disk. Now, the reason is that if somebody wants to do some kind of analysis, post analysis, right? So map it, what happened, when happened. Looking real time is good, but maybe you want to do some kind of profile. Again, this is happening separately in a separate thread, so it should not slow down your training at all. As I said, I am working on a live browser dashboard. Initially, it was Streamlit, but the Streamlit has some certain issues, so I'm looking into something else. And I have a lot of requests, people asking if this could be done in a multi-GPU distributed scenario. This is something that I plan to build it, but this will take some time. Yeah. So that's all from my side. Any questions that you might have, any concerns? I saw that one of the comments was on the LinkedIn that this is very similar to weights and biases.
Oh, yeah, yeah.
Um, yes, so I haven't used extensively weights and biases, but I don't think it looks into memory in the Pytorch level.
Yeah, it doesn't.
To
It
me,
doesn't.
yeah, so to me, it's more like a log that you are trying to create during the experiments.
Correct.
With TraceML is more like a lightweight profiler, so it's trying to understand
Hmm.
from the user's perspective what is happening, right?
Yeah.
Um, yeah.
So what's interesting is, I mean, weights and biases is more of an experiment management platform now, and you could log your artifacts. It's like complete ML ops and LLM ops you
Yeah.
can take care of. But I think what would be interesting to see is combining TraceML and weights and biases. So weights and biases also has this option to do Bayesian optimization of your hyperparameters, like, and then
Mm-hmm.
figure out a good Pareto friend for your deep learning models, right? So now let's say
Mm-hmm.
if memory were to be a constraint. So far there's no way to mention these as constraints, right? So I was
Mm-hmm.
wondering, like, it would be really nice to see if we could get, let's say, memory layer wise memory or accumulated memory for certain layers or certain blocks, and use that as a metric to really optimize the hyperparameters further. Or
Yes. So that's interesting point actually. You can think of so there is one way that you often it is thought about experimentation is you're trying to improve a hyperparameter tunet of you know to get best metric, right? So some machine learning metric, but you can in um, you can take and think of doing parameter tuning over memory parameters.
hmm,
So the goal here is not particularly optimizing, any ML metric. It's more about optimizing or ensuring that
hmm,
your program runs more. So one of the things that is very important to keep in mind is that, and I can later send you if you want papers about it, that majority of GPU that is being used right now, um, like 60% of it is only being used. So roughly, there are statistics which says roughly 40% of your GPU goes wastage. And this is what my effort is trying to do here. That you try to avoid that wastage or at least lower it. So give visibility to people so that it can lower that wastage that is happening, right? And GPU is very costly these days. So yeah. So
nice.
you can, yeah, sorry.
Yeah, you can. Sorry.
I'm saying you can do hyperparameter tuning, but in that case, the goal would be to see if there is no out of memory or there is like
Hmm.
the end metric to look at would be either use all the memory or maybe all use all the compute, right?
Yeah.
So like yeah, something like that. So you're hyperparameter tuning, and then you're looking at how much time does it take to solve whatever problem you're doing.
Hmm. So, just one question. So, does it? I don't remember seeing. Does it make? I mean, does it even show the GPU utilization here? Like, just
In this case, in this one, it's not showing, but yes, it does show GPU utilization.
okay,
I don't have a GPU on my laptop. I have it. It's a MacBook, so I have to write it in MPS one, but
okay,
not the NVIDIA. So it does have an NVIDIA inside. So it looks at NVIDIA basis. Yeah.
okay. So, there's one question on the chat where, like,
Yeah.
the question is to know if TraceML works with pre-built third-party models from libraries such as Hugging Face.
Good question. So yes, it does. So this is the example that I made up for specifically for this particular talk, which is going to be there inside now, since it's simple. Here, um, you have. So this is an example by default within the tool, and what I'm using here is the dilbert from Hugging Face. Right. So it's a standard transformer that I'm using. As long as the model has Pytorch base, like it's written in Pytorch and not something else, it will work. That's not a problem. Yeah. As you can see, I think there is a hook happening somewhere. It's a little big code, but yeah. So yes, there is nothing I'm special doing, right? So this is the model that is coming from BERT, and I'm just passing the same model to a trace mode, so it works. It might have different cases when, like, in the case if you do some kind of fusion. So there are certain cases where it will not work, like if you do some kind of compile, torch.compile, which is new, and it kind of fuses some layers together and some parameters, in which case you might not have backward pass running, and in that case it might get some garbage or might fail, but I haven't tried that. For majority of simple cases it should work. Majority of current cases, let's say. Yeah.
Okay, so in that case, I mean something like TensorRT or even Onyx kind of fusing of kernels would not.
Might not work. Yes, I haven't tested it on those things
Okay.
yet.
Okay.
It might not work. Yeah, it might work. Not showing any errors because I have done everywhere catching up those, but you might not get the result you intended, right?
Okay.
Because certain layers would not be doing hooks, won't be running hooks anymore, and then there will be like empty values there.
Okay, but I think that way, even then, I think it's good to have like some sort of an A and B, right? So A is like the model without any fusing or compilation, and B is the model with compilation, and we actually find out which are the blocks where it is actually skipping. Right? That could give us some,
Yeah.
right? So some kind of information on, yeah.
Yes, it does. Means I'm looking into what you're calling as so what I'm calling as a verification system, right? I am looking into ways to. I'm thinking along that line to how to verify in some sense, right? And what is missing, what is not missing, what is actually happening internally. But for me right now, the goal is to make it first, see if it's useful for people, right? So if there is interest in people to use this, and what kind of feature might interest them, right? So in future, like I have certain ideas that I want to do with the tool, but it might be more interesting to see how people use it and what they would like. For example, timing came out of this from what end users said that they wanted timing.
Okay.
And you talked about GPU, so there is some discussion on how GPU would look like. So the tool has been built. It's let's say a first version that is out yet. Yeah.
Okay. What would be really useful also is, like how we could also further optimize GPU utilization of these models when we build one.
So you want to take TraceML? Yes, it could be. So one of the things that could be done, though it's going to be costly, or at least to figure out how to do it smartly, is take the tracing and pass it to some kind of LLM to help you there, right? So it tells you, hey, this particular level or layer is using this much of memory. Maybe, so I'm building it, but yeah, compute time, and maybe we should look into it, try to optimize into it. Because all that information is there, right? So right now, once the JSON export is there, all that information will be out on the disk. So post-processing could be done after that. Somebody can feed that into a LLM, and maybe it will answer it. It will be a big log to put it, but I think you can do it smartly or something.
One fundamental question. So let's say people are building models bottom up, right, from scratch. And as someone who has developed TraceML and is looking into verification and filing and all. So how would you, what would you recommend? So how do you think people should go about building these models from scratch, and how could they leverage TraceML for this?
Um, okay, if you're building it from scratch, this is where the TraceML kind of pitches in a lot. Because what you want to look at is memory, right? So when you're working in an industry, people are worried about how much energy you are spending, how much GPU are you are spending, and this is very important, right? This is where TraceML can help you to understand what is happening. Um, is it slowing down? So maybe you're not using the system at all, or maybe you're not using the system at full capacity. Maybe there is some computation in particular which is taking a very long time. So this will help you design the models or the layers itself. Maybe you reduce the layers, maybe you break it up or split up the layers, maybe you parallelize it somehow. So this will help you to understand that aspect of it. Um, and another important feature, which I have also faced personally, is the errors that you get. Like this is where it started all of this whole tool. Errors are very thing. You run the project, you train it. After 1 day, it cancels out. 2 days, it just gives a big out of memory, and you don't know what is happening. So this is where I think the TraceML can help you to figure out exactly what happened, which particular layer ballooned up or got bloated, and where is the leakage happening. So this helps you to optimize the model. Somebody, let's say, who is doing fine tuning, right? So suppose somebody is doing fine tuning on, there are many ways to do this fine tuning, and often the consideration is memory. All these different methods like LoRa, quantum LoRa is based on idea that you want to ensure that your model fits into the GPU, and this is where TraceML can help you to figure out if it is actually fitting it up or not, and you can actually see how much memory it's taking. What is the current batch size? How should the batch size should be changed over time? So one of the things that you often go through is multiple batch sizes, right, to find out the best trade-off. But that's very manual process. Even right now, it's also manual in this case, but at least you get a visibility what is happening.
Yeah.
Right.
I think this would even give us very clear indication of what can the batch size be, right? Like,
Yes. Yes, it can give you. You can have a simple plot which tells you with batch size how is the GPU usage and if you're getting any out of memory thing or not.
yeah,
Right. So it can tell you, yeah, what to use and what not to use.
yeah,
Suppose you for very large batch size, okay, GPU is filling up nicely. You're doing maximum computation, but then it will slow down because since the batch size is large, you would have to transfer data to GPU. So in that case, you can see that slowness is happening. So okay, let's go and optimize the data load part. Maybe spawn multiple workers there, right? So you do something like that, and then for multiple workers also, how many number of workers? So you can all see all that because it will tell you, okay, because you have put a decorator, it can tell you how much data loading time is taking for the next batch to get it. So it is kind of a tool that helps you optimize your model in the best scenario.
okay,
And the good thing is about that you don't have to know anything in particular to use the tool, not a lot, right? Like you don't have to know the internals of Pytorch, how it works. Sometimes it crashes, but I suppose you don't have to know this. You all you have to do is use the simple hooks. They are not computationally extensive. They're like very simple. They're looking is metadata information. They're not doing any compute. So for example, weight and biases does this log normals and gradient. There is a compute happening there, but we are not doing any compute on GPUs. All I'm doing is just looking at the tensors data, metadata. So this is faster and doesn't slow down your training.
No, I think even as a diagnostic tool, right, this is very helpful because, like, if, I
Yes.
mean, let's say we're not looking at the end model, which is the final model that we're training end to end, but even in the process of developing a model, I think this should be used as a diagnostic tool to begin with, and then consider these aspects
Yes,
from the beginning, right? Like, I mean, not look at it later once you have rounded up on certain hyperparameters and then find out, oh, this is not optimal in terms of GPU utilization or even memory, right?
yes, this is often the case, right? So you come up with nice models, but when you go to put them in prod, it fails.
Yeah.
The batch sizes are changing, or you have a
Yeah.
different data set coming up, or maybe it's not optimized, right? So it's slow.
Yeah.
And this is where it helps you that you don't have to do this in sequential order. Usually, people fit the model, they have a nice result, metrics, and then they work with engineers to figure out how to fit the model, how to optimize that particular model. And this gives you the picture at the same point. So you can think of it together. You don't have to take it in a separate thing that engineers will look at it later if you have
Yeah.
something. Yeah.
And have you tested this on diffusion models? Like,
Uh, I haven't tested on diffusion models now.
okay.
I have looked only on Bird that's been working, but if there's a request, I can look into it.
But I think even there, it becomes straightforward because you, of course, have multiple function evaluations that happen in diffusion models at inference. But I think even a single function evaluation, if you were to profile, I think that gives it's representative of what memory or time it would take for rest of the iterations that you would possibly do at inference, right? I think.
Yes. I mean, I don't see why it would not work in particular
Yeah.
case,
Yeah.
because the way the model treats it's that it's any Pytorch model,
Yeah.
it's agnostic, no? So any Pytorch, as long as it's Pytorch model, it should work.
Yeah.
But yeah, if there is some optimization that has been done internally, then it might not. Then it might be that it not works, but I don't see any reason right now, like why it would not work on a diffusion model. Any Pytorch model should work anywhere. Yeah.
That's great. Yeah.
Okay, I think that's. If there are no questions, then maybe I can end this.
I think we discussed most of the things, most of the key questions that we had, and also the ones that we found on LinkedIn. Right, I think covers a good
Yeah.
deal of key points. I think. Yeah. Yeah. Any questions from the audience? Other questions from the audience? Okay, I think if not, then I have one. So which is more beginner friendly.
Yeah.
How do you think people should start looking at, like, let's say if people are doing their ML courses now as students,
Okay.
and then how do you think they should look at optimization of memory, all of this, right? So from the hardware point of view and actual production point of view. So how do you suggest people go about it, and any
I think
resources that you would recommend?
this comes from experience mostly. If you are just starting up in this domain of machine learning, majority of focus is understanding the machine learning. So it's very important to understand the basics of it. Very often you see that people have trained very nice models, but somehow the basics might be missing or they have forgotten or something along the way. So I think that's the most important thing, that you focus on basics. Um, and when it comes to optimizing on the production, right? So you would have to figure out wherever you are working that how does the production system look like. But it is often a good to have some information about parallel computing in general. Like how does it work? When you don't need GPU for that, any CPU could do it, right? So you can just look into how threads are created, how threads are working, what is how are different libraries working in case in CPU, let's say. So people look at Pytorch, but I come from a background where I've done all this in C, like understanding P threads and fork. Like how does the differences exist? Like, and this is important to know even in the case of Pytorch. Like how does the data parallel happens and how does distributed data parallel happens? What is the difference there? Why are those things differ? Um, so that helps. And then what also helps, apart from parallel computing, is knowing the architecture itself. So there are a lot of lectures on specifically on CUDA. You don't have to go and write your own CUDA code, C code on CUDA. You can just go through the lectures and understand how the system works. And it would be good to understand the difference between the CPU and the GPU. Like, what is that difference? Why does it ensure that this is much faster than the average CPU that you have? I think if you have that basics clear, like the mental picture of
Yeah.
CPU and GPU and the basics of parallel computing, I think understanding all this becomes pretty straightforward. Yeah.
That's great. And any resources that you would recommend? I mean, learning resources.
Uh, for for parallel systems, you mean?
Parallel systems. Yeah.
The one that I haven't done the parallel systems in a long time, but usually for PyTorch already provides a nice tutorials. I think that's the best way. There is one called as Apex ML, if I'm not wrong, maybe.
Apex ML. Okay.
Apex ML. So it has a course on PyTorch and it has also a course on advanced PyTorch. So you can go through it. It's a reading, it's not a video. One can go through it to understand this. That's what I've been using myself in the past. And then there's a lecture, if I'm not wrong, from Stanford about CUDA programming. Now, in that particular lecture, they talk about programming in the CUDA itself. So they are using C as a back, but it's a basic program. To be honest, they're not telling you anything. But the important thing is you get to know the architecture. And the lecture, I think, starts with explaining the difference between CPU and GPU architecture.
Okay.
So you get this. For the basic ML, yeah, I mean, there are a lot of information available, right? So the best course is like Andrew Nick.
Yeah.
You don't want to miss that.
So that's the starter course for anyone getting into ML.
Yes.
Yeah. Yeah, I think that's it. I think if you have any questions for us, if you have.
Yeah, I think it's good, but the initiative that you've taken, it's the right time to do these things, I suppose. There are a lot of interest, a lot of questions that people have in general, what to do, how to do, and I think that the advice is scattered there. So it kind of gives you a central platform to do this.
Absolutely, yeah. And I think, I mean, thanks to people like you who are willing to spend their time on weekends and talk
No
to us
issues.
and educate us on certain things, right? I think this is really helpful. And I mean,
Yeah, I'd also like to add that, yeah, thanks again, yeah, and then Rahul and others also for joining. So this is what Rahul started is like an organic initiative, basically building community. It's like a threesome kind of a thing, right? Community, then education, knowledge sharing, and also then discussing forums and all of the above. So any thoughts and ideas also welcome. But I think it's like when it's always good when you start small and slowly like expand and be like a nice organic thing that develops. So that's another thing that's sort of sharing.
thanks, Lakshman. Yeah. So Lakshman has been like supporting in terms of morally and also in terms of ideation and a couple of other things as well. So he's a prolific scientist. He has background in now computer vision. He has background in malware detection, a couple of other things, and he's worked on multiple DARPA projects. And he's worked with Sri SRI Lab. So
Okay.
yeah, so
Yeah, I think there are a lot of people. There should be a lot of people who should be willing to talk and explain on what they have been doing. There are a lot of tools coming up. There are a lot of papers like crazy. You can't even keep up.
yeah,
I think at this point, conference can't keep up.
yeah.
So I think there are a lot of information, and it's very important to put out what is the right information. Otherwise, it's very easy to get drowned into some corner.
And
It's a great initiative. Yeah.
Thank you. And okay, now that you mentioned it, I have another interesting idea. Just throwing it out here.
Hmm.
So, so I mean, when we conduct walkthroughs, I also announce some sort of a micro challenge or some sort of a good first issue that people could work on, right? For any first time open source contributors trying to figure out how do I even go about open source. So I was wondering if we could possibly design some very simple micro challenge that, and also ends up being some sort of a contribution to your package, while also people learn more about the TraceML package itself and also get introduced to ML optimization and stuff.
That's
I
actually a
can,
very
I
nice
can.
idea. Like, Rahul, just you. Yeah. So from my side, I'm like just followed at a high level. So what could be helpful? I can try from my side, but again, Abhinav, you can also suggest other things. From at the very base level, no, I can just give it a a base try, like a very raw try. Okay, go to TraceML, go to the GitHub repository, and as an end user, just try and see, get a feel for it. And maybe Rahul, we can come back and have like some maybe after a couple of weeks or so, I mean, whoever has actually done that, and then maybe have a session with feedback slash user feedback session plus, and or like if you want to post some extra challenges and other things also, that could be a good way to both. It will be like, it will not just be like, okay, you gave a talk about your package today and that's good, but it could be like one more circular, like continual thing. So just thought adding to on top of what Rahul just said, you can try something like that. Like.
Yes. I think. Yeah, that would be a nice. Means from my perspective, it's always good that people try it out. More and more people and more input I have. One of the things is that it helps me to figure out where to go based on user input. One thing that could be done also is taking a little bit further. It is good that you install that, try it out on a model that you have in your own side. Is also that separate small issues that you can create, or I can create if somebody is willing to contribute. So you can look into those issues and work on it independently. It could be a smaller, simple issues, not something very complicated architecture-wise. And see if, for example, adding up a new panel, can you do this? Or maybe you know writing few examples. So as Rahul said, can somebody write an example for stable diffusion? Does it work? Or I don't know if it fails or something.
Yeah.
So it gives the angle that it's been explored in different areas, and it's more, and then we can work on it together. So this would be more contributory. If it doesn't work on, let's say, for example, on certain stable diffusion, we can look into why it doesn't work and how could we do this. Similarly, as Saul said, like torch compile, right? So what is happening? Maybe we can figure out what I have in my view, a simple view of showing results, maybe a better view, like show something else, like okay, what is happening when you're doing compile actually. So yeah, that would be quite interesting to come back and again see what users' input are and how can we improve. Maybe after the call, Rahul, I can later, not today, maybe later, I can send it to you something if people are willing to
Sure,
do
sure.
this.
That would be lovely. And because
Yeah.
what we tend to do is once the talk is done, we upload it on YouTube. Then we planning to have some sort of a YouTube highlight of 3 minutes or something, and then also highlight it on LinkedIn. Then want to have a spotlight article on Substack. So any such relevant resources that you could share even after the talk as some sort of a call to action, that would be very nice. We could put it up as part of the
Okay,
article.
sure. Okay. Oh,
I think
I think.
I think that's it, and I think we are just on just on time. Yeah.
Yeah. Okay.
Thank you. Thank you all.
Thank you everyone.
Thank you.
Thank you everyone for
Have a
attending.
nice weekend.
Thank you Abhinav
Thanks,
once
Mr.
again.
Abhinav.
Thank you.
Thank you.
Thank you.
Bye.
Thanks Abhinav. Yeah. Nice connecting with an alumnus as well.